Good evening, learners. My name is Mr. Particulate once again, your teacher in Igcse Combined Science. Recall that Combined Science constitutes three minor subjects, namely physics, biology, and chemistry. I intend to introduce to you a chemistry component of Igcse Combined Science. And if you are accessing this lesson and you feel it is relevant to you, then you must be in Form 4 or Grade 10 of your Igcse Combined Science course. In this presentation and the others that are to come, our target is to lead students to scoring an A star or an A, or if things don't work well, a B. These are students that qualify for the top tier of a Cambridge exam score, which is called A star. And this requires that they should sit for the subject in the papers 2, 4, and 6. Remember that paper 2 is a paper meant for extended class. It's multiple choice paper containing physics, chemistry, and biology topics, but in multiple choice format. And also paper 4 is a theory paper. A theory paper meant for an extended group. The paper also contains some physics, chemistry, and biology topics. And then later on, in a paper called paper 6, which is an autoprac, or as it is sometimes called in short, or alternative to practical. My name once again is Mr. Particulate. I am classified by students that I have taught before as the distinction teacher. In case you want to reach me to ask me questions based on the material that I teach, do not hesitate to reach me on the number that has been shown on this screen, which is 088-434-1022. My target for teaching here is my own students who are currently in Form 4 at the Karibu Academy. But should you happen to be a student who is at a different school, since this lesson is placed here on YouTube, you can learn for free, and at the end of the lesson, I invite you to come to Karibu Academy and meet the best teachers whose passion is nothing but to teach and to bring out the best out of you. All right, so we invite students from anywhere in the world to join us at Karibu Academy, the spirit of excellence reaching the heavens, where we do not relax at anything, but we embark on bringing out the best of a child, which is to teach, to impact, and to change, based on a principle which is called listen and obey. Through the principle called listen and obey, we have managed to transform lives that are now able to look back to Karibu Academy and say thank you, because I passed through the corridors of Karibu Academy. I am where I am today. So through the principle of listen and obey, we have managed to make legal practitioners, bankers, nurses, doctors, lawyers, teachers, professors, lecturers, and many other fields that I cannot manage to mention one by one. But the current lesson is intended to those who are currently in my class at Karibu Academy, the place of excellence, the institution of excellence, where excellence is not just a word, but a practice. Once again, welcome. My name is Mr. Particulate. Don't hesitate, if you are new, to subscribe to this channel and also contemplate on joining us at Karibu Academy, where we are doing nothing but the best in teaching. So welcome to this Form 4 topic of combined science in a component called particulate nature of matter. Particulate nature of matter. It's a topic, the first topic at Igcse Form 4 combined science in chemistry. Particulate nature of matter. Okay, I always say that in order to understand any topic, you must define it. So let's just look at some keywords in the topic. We have particulate. Particulate means having to do with particle. Nature refers to the form of existence. The form of existence. Nature, the form of existence. Of matter. Matter, remember, that is anything that has mass and is capable of occupying space. So particulate nature of matter is referring to the particle, the particles contained in matter. I think that's what we'll be talking about. So we are saying matter has particles. That's what the topic is basically going to address. Particulate, having to do with particle. Particles are small bits of anything. Think about plastic paper, like this. Plastic paper. Think about the matter or the stuff that makes up your body. It's made up of particles. It's matter. Think about substances like air, water, blood, wood, soil, rocks, the walls of your classroom, the particles making up your bag where you put books. It's made up of small particles. And those particles group up together to make what is called matter. Of course, you know the word matter is used in other sectors outside science. You say, does it matter? Okay, is it important? Anyway, but here we are talking about matter as anything that can be put in a space and it has a property which is called mass. For example, you fill up a balloon, it is going to be inflated with air. So air is, in that case, matter. So we are looking at the particles that make up the air in the balloon. If you fill up water in a tumbler or something, all right, so the space in the tumbler will be filled up with water by the particles of water. Particles. So particles are just the bits, small, tiny particles which we are going to talk about. I hope you have a gist of the topic, what the topic addresses. So quickly, let's define matter. What is matter? All right. You can define matter the way you want, the way you like. Okay. You can say matter is this, matter is that, matter is this, and all that. As long as the definitions you give make sense and are not turning away or deviating away from the scientific meaning. But for now, let's define matter as a substance that occupies a physical space. Of course, some would say matter is any substance that occupies space and has mass. No problem. Yeah, so matter has mass. It also has the tendency to occupy a physical state. Physical state means physical space is a space where you can see. Physical. Like the space in a cup, in a beaker, in a tumbler, in a dish, in a bowl of sugar. You put sugar in a container. At the breakfast, the sugar occupies space in that container. Therefore, the sugar is matter. Yeah, let's say you inflate a balloon, blow a balloon, so it gets bigger, you fill it with air. Yeah, what do you say? The air is occupying space in that balloon. So therefore the air is matter. So think about any space where something is placed and it occupies that space. So that which occupies space is matter. And so you can also use a beam balance or a digital balance to measure how much heavy that substance is. So it also has a property which is called mass. So definition of matter is any substance that occupies physical state, and you can add to say that it has mass. Mass is just how much of something is, a quantity. You will learn this as we go. All right. So define matter there. So matter is any substance. Think about any substance. Think about the tea you take in the morning. Take the bread in the stock brew bun that you smear on the loaf of bread or slices of bread. Oh, those are examples of matter. Water you drink is matter. Air that you breathe in is matter. All the stuff around you. Think about your own clothes. Think about your own wardrobe stuff, your beddings, and all those things that are in your room right now are matter because they occupy space. And also, if you happen to determine their mass, how much quantity they contain, then they have mass. So matter is any substance that occupies space that is physical. So in order to understand the behavior of matter, it is important for you to understand what is called the kinetic theory of matter. The kinetic theory of matter is just a statement which is true based on experience carried out in different substances. It says that the kinetic theory of matter states that matter is made up of tiny particles. So think about anything that you lay your hands on. Think about anything that you see and that which you don't see, like air. Think about the food you just partook. Think about the clothes that you wear. Think about the air you're breathing in and that which you're breathing out. Think about all these things. They're made up of tiny particles. So the particles can be the atoms, which we will look at in a separate topic, molecules, ions, radicals. Don't mind about these things I'm mentioning, radicals, what stuff. Yeah, they'll come clear as we go. And they always are moving at a constant speed. We say they are always in constant motion. So if you go back to your study room, there's a table. So the table in there is made up of tiny particles. These tiny particles are not just stationary, they are moving. Of course, you cannot appreciate their movement. They are not moving in a way that you can understand, that you can see. But they are moving anyway. Air, the air you breathe in, you can't see it. But there is air in your room, there are particles that make it up. These particles are always moving. You get yourself a glass of water to drink. The water in the glass that you have is made up of particles that are moving, the molecules, the water molecules. That's what the kinetic theory is saying. That's what basically we are saying. So the kinetic theory of matter helps you to understand the behavior of particles. How do particles behave in general? So you've got to know the kinetic theory of matter. You'll be asked in an exam, a question will come in paper 4 to simply ask you to state the kinetic theory of matter. Then what are you going to say? So you will say the kinetic theory of matter states that matter is made up of tiny particles that are always in constant motion. So you usually have 1 mark for it. If you say it correctly, beautifully, you get 1 mark. And I always emphasize to my students that 1 mark matters. 1 mark that make a difference between an A star and an A, or the difference between an A and a B. So you can't afford to miss the statement of the kinetic theory of matter. So what does the kinetic theory of matter says? So what does it state? It states that matter is made of tiny particles. That's not difficult to say. And that these are in constant motion. So the particles, you may want to say what particles these are. It can be atoms. Remember, atoms are the tiniest particles of matter, containing electrons, neutrons, and protons. Sometimes the particles can be the combination of atoms, which is called molecules. Okay? All right? So defined matter, matter we're saying is any substance that occupies physical state, or a substance that occupies space and has mass. So how do we understand the behavior of matter? It's by understanding the fact that the kinetic theory of matter is a statement that says matter is made up of tiny particles, and these particles are always in constant motion. Constant motion means same speed, constant speed, moving in constant speed. In case someone asks you how many different types of states of matter do you have? So we have 3 states of matter, 3 types of matter. So we are saying there are 3 states of matter that you need to be aware of. Namely, we have what are called solids, liquids, and gases. In case someone wakes you from slumber to say, give us 3 states of matter, you simply say solids, liquids, and gases. So we are going to, in this topic, lesson, to talk about solids, liquids, and gases in detail. All right, so pictorially you can see that solids, liquids, and gases can be represented like this. Pictorially, you can see that the particles making up a solid are touching each other. They are in some kind of pattern. You see they are in lines. They are arranged in a regular pattern. Compared to liquids, you see the liquids are sliding over each other, meaning that one particle of liquid can slide over another like that. But solids are arranged in fixed regular pattern. Whew, look at gases. Gases are just sprayed far apart randomly. You see this particle now, you have this particle like that. They are sprayed in different directions. An examination tip, there will be a question that says, draw a diagram to show the arrangement of solids in, or particles in solids, liquid, and gases. So don't forget, this is the order. So usually you may have 1 mark or 2 marks depending on the wish of the examiner. So let's look at solids. How are solids as state of matter described? So solids have particles that are packed closely together. What we mean by this is that when you're looking at particles in solid, the molecules in solids, the atoms in solids, you wouldn't see space between them. They are touching. They are in contact, physical contact with each other. They are not touching each other. I mean, they are touching each other. There are no spaces between them. So we say they have particles that are packed closely together. They are packed closely together. Particles in a solid are closely packed together. So the atoms are arranged in an order, like a regular pattern, due to strong attractive forces that exist between the particles. So wait, what are we saying? We are saying that when the particles in a solid, think about a rock, for example. It's an example of a solid rock. So the particles in a rock are packed closely together, meaning there are no spaces between them. No spaces. You can't see a single space between the particle and another particle and another particle in a rock. I'm just using rock as an example. What? Let's think about another type of solid. Let's say a piece of chalk. If you look at a piece of chalk, you wouldn't see individual particles with spaces between them. The particles are tightly packed together. So the atoms are arranged in a regular. Regular means a systematic order. Particles being arranged in a line. So you have a line, another line below it, another line below, another line below of particles arranged. We call that regular pattern. Why the particles are arranged in such a regular pattern is because there are forces holding the particles together. These forces are called strong attractive forces that exist between them. Of course, you'll learn about these forces in much greater detail. So these particles therefore cannot move. Instead, they vibrate constantly on the spot. So particles in a solid, you can't see they're moving from point A to point B. You can't say that particle has moved from that point, then to that point, and that point, that point, that point. No. They simply vibrate on the same position. Particles in a solid vibrate on the same position. They don't move from point A to point B or point B to point C within the substance. They simply jostle. They simply vibrate. You may say, how come I don't see them vibrating when I'm looking at the particles that make up a table? Yeah, you can't see The particles are vibrating still, despite you not seeing them. The particles are vibrating in a manner that is insignificant for you to see the vibrations, but they're vibrating anyway. So we are saying 3 points are important about solids. We are saying the particles are packed closely together, one characteristic. 2, the particles are in a regular pattern. Regular pattern simply means that they are ordered. They are in a line. For example, you students, when you are asked to queue up for something, and you are asked to line up in a straight line, you are also arranged in a regular order or regular pattern. So the particles, the small particles in a solid are arranged in a regular arrangement. Why they are arranged in a regular arrangement is because there are forces that are holding them together so that they are not so free to move from point to point. So these particles therefore cannot move, but instead of moving, what they'll do is to simply vibrate about the same position. So 3 points are important about solids. 1, they're closely packed together. 2, they're arranged in a regular pattern. 3, they cannot move. Instead of moving, they're simply vibrating about fixed positions. Points about solids for you to note. These are the ones that I've just mentioned. So, in order to get them to move, you need to give them energy. We are saying that particles in a solid don't move that much. They don't have that freedom to move that much. But for you to get them to move, you must give them energy. And that energy is in form of heat. So when heated, the particles will begin to vibrate strongly. They'll begin to vibrate vigorously as they gain more energy. Remember, this energy is basically kinetic energy, which is the energy of movement. All right? So 3 points are important to remember all the time. First and foremost is that the particles are closely packed together. 2, that the particles are held together by strong attractive forces. 3, the particles cannot move, but they vibrate about fixed positions. So to get them to move, you'll need to heat them up. So when you heat them up, they gain an energy form which is called kinetic energy. So the kinetic energy will eventually cause the particles to separate out, and they start to overcome attractive forces or attractive bonds. So eventually the particles will have enough separation to move from one point to another, but still kept relatively close, as attractive forces between particles to exist. So the solid now officially becomes a liquid. All right, so in short, what we're saying is that for you to get a solid turned into a liquid, first of all, notice that particles in a solid are packed together, and that they are arranged in a straight line or regular pattern, and that they are simply vibrating about positions. So how can you turn a solid into a liquid? It's simply by heating. So when you heat, the particle is going to gain, the particles gain kinetic energy. So the kinetic energy will cause the particles to separate apart, to move apart, to separate apart. As a result, what's going to happen? What's going to happen is that they will have enough energy to separate, to move from one another, or to move past one another. But still they are relatively close. So when that happens, we say that the liquid has now, the solid has now become, officially has now become a liquid. So how does a solid become a liquid? 1, you need to heat it. When you heat it, the particles in it will gain kinetic energy. The kinetic energy, remember kinetic energy is energy due to the movement of particles. So the energy, the particles will gain energy which is going to enable them to move far apart or to slide over each other. So in so doing, the solid becomes a liquid. So what happens in a liquid? So therefore, liquids have particles that are loosely arranged, meaning that they can move past one another. That's why liquids do flow. Liquids can flow or they can slide over each other. So they therefore take up the shape of the container in which they are. The particles themselves are constantly moving in constant motion, a random motion. So we're saying when a solid turns into liquid, the particles will slide over each other. One particle sliding over another particle, sliding over another particle, and so on. That's how water behaves. When you're getting water and you're pulling water from a container, what's happening? How is it possible for you to transfer water from one container to another? It's because water particles are capable of sliding over each other. But what is even more striking is the fact that liquids shall always maintain the shape of the container in which they are. The particles themselves are constantly moving in constant random motion. If you get water from a big cup and move it to a measuring cylinder, it's not, by the moment it is placed in a measuring cylinder, the water will occupy the space in the measuring cylinder and it will take the shape of that measuring cylinder. If you get the water into, say, a round bottom flask, it will take the shape of that round bottom flask. If you move the water from somewhere else, in another container, the water is going to take the shape of the container in which it has been placed. So, let's say you continue heating the water. What's going to happen if you continue heating the liquid? So if you continue heating the liquid, the particles will gain more energy. And this will separate the particles even further apart. And it does this by overcoming most of the remaining forces of attraction. All right? So listen, we are coming from solid. We said that particles in a solid are tightly packed together and that they are not so free to move by themselves. But if you want to get the particles in solid to move, all you have to do is to heat them up. When you heat the particles in solids, what are they going to do? They will absorb heat energy. The heat energy will cause the particles in it to move further apart, to slide, thereby making a liquid. But now, let's say now you are heating the liquid. As before, the particles in the liquid will going to gain more kinetic energy, which is going to cause them to move far apart. And this time, they're going to move far apart in different directions, in a direction which is called random motion. So we say gases, therefore, have particles that are very far apart, and again, the particles will be moving in constant random motion and also take up the shape of the container. For example, if you inflate a balloon, the particles in it are going to fill up the whole balloon. Unlike solids and liquids, gases can be compressed. You can compress them, you can squeeze, you can squash them. Let's say you inflate a balloon. You tie at its end, at the mouth there. There's air trapped in the balloon. You can squeeze that. The reason why the balloon eventually bursts is because the air particles are trying to squeeze themselves closer to each other. So we are saying particles of a gas, unlike those of solid and liquids, can be compressed. Bear in your mind that if you start to make energy away or to take energy away from the gas, then individual particles will have less energy to overcome attractive forces and will eventually turn back to liquid. So what we say is that if you are to get a gas back to solid, all you have to do is to cool it. By cooling it, it means you are removing energy from it, and the particles in it are going to now start coming closer to each other, and eventually they are going to form a liquid. In a similar way, by cooling a liquid, it is going to turn into a gas. So what we're saying is this: if you heat, this diagram is showing you that if you heat a substance, a solid, for example, it's going to turn into a liquid. The particles of a liquid is going to look like this. All right? So the particles will look like this, and if on further heating, the particles will now tend to move far apart. So they'll ask you a question to say, use the kinetic theory using diagrams, show the arrangement of particles in a solid. So in a solid, you just have these particles that are arranged in a regular pattern. In a solid, the particles will tend to slide over each other, but they are still in a regular order, but not as regular as in the solids. Further heating will show that particles are spreading apart, as it is the case in gases. Very, very important. So there is a name for each of the respective changes from one state to another. That's from solid to liquid and from liquid to gas. So we are going to look at the diagram for this and how we can best explain this change. My name, once again, is Mr. Particulate. I appreciate that you are there, and I appreciate that you exist as my students, because without you, it's not possible for me to teach remotely like this. I wish you the best. Okay, just before you go or when you exit this video, check in the description below. You're going to find some exercise there. I want you to do that exercise and get it downloaded, printed, and then bring back to school, where I'm going to see and appreciate. In the name of Jesus Christ, our Lord, I wish you the best in your holiday and everything that you are doing. For now, it is a big bye-bye.